relation between the compound and the ion it produces and dilution. Sulfate solution should be required to make by dilution. So here we have dilution. So you should recall the law of dilution. Number of mole before dilution equals to number of moles of solute after dilution, because by adding water, number of moles doesn't change after dilution. This is the first thing. The second thing you have to know, because our work is in solutions, number of mole equals to concentration times volume. Then we convert the relation into what? Into N1 equals to N2. So C1 V1 before dilution equals to C2 V2 after dilution. No need in case of dilution to calculate the number of mole, then use it to calculate other things, because one step better to be omitted, which is dividing the volume by 1000, then multiplying it again by 1000. So in dilution, no need for changing the volume into decimeter cube. Here we have potassium sulfate, and what is potassium sulfate? K2SO4. And they ask us how many potassium ions, what is the volume of 0.2 to give to make 1 decimeter cube solution of what? Potassium ion. So we need to write the equation of dissociation of this salt, because they are not asking us about K2SO4, about a species produced from K2SO4 by dissociation of K2SO4. We balance it. This is 2. We have, this is the given, this is the required. So one of the steps is to use stoichiometric ratio. Every 1 mole of K2SO4 gives 2 moles of K plus. Clear? The given is in concentration. We have the concentration of potassium sulfate. In similar questions, always, because both are in same volume, use the concentration relation. Then we can write 1 mole per decimeter cube of K2SO4 gives 2 mole per decimeter cube of K plus. Why? Because V is the same. V is the same for both. Because V is the same, 1 mole per V gives 2 mole per V. Whenever the substances are in the same solution, then mole ratio and concentration ratio are the same. Clear? In this case, 1 mole per decimeter cube gives, as we said, 2 mole per decimeter cube K plus. Then what is the given? 0.2 mole per decimeter cube of this give K plus of concentration 2 times 0.2 mole per decimeter cube, which is 0.4. Okay, which is 0.4. Now we have the concentration of K plus before dilution. Before dilution. To start the calculation, we need to know before dilution to know after dilution. What volume of this is required to make by dilution with water 1 decimeter cube of concentration this. So the C1 V1 equals to C2 V2. I need to know the volume to be taken. They call it V1 equals to C2. What is C2? C2 is 0. What? 1 multiplied by the volume is 1, state the unit decimeter cube, divided by what? V1 equals to C2, V2 divided by C1. C1 0.4, we calculated it. Clear? So if we need to find the volume of K2SO4, then we use the concentration of K2SO4. But they ask us to calculate the volume that produces the potassium ion. So we need to use the concentration of potassium ion in calculation. Always bear this in mind to know what the consequence of the steps you are going to follow. So what will the answer be? 1/4, it is what? 0.25 decimeter cube equals to 250 centimeter cube. This is the answer.